Finding the right configuration resources in a sea of server assets shouldn't require manual digging through every file. We'll use FastMCP's metadata tagging system to programmatically filter and locate only the config resources we need, showing how the FastMCP, namespace, and tag-based queries make resource discovery precise and efficient.
Async with client. Resources equals await client list resources. Hash filter resources by tag. Config resources equals resource for resource and resources. If hasheader, resource, meta and resource meta end. Resource meta get FastMCP end. Config in resource meta get FastMCP get tags. Print f found len config resources. Config resources.
This demonstrates the metadata filtering pattern for resource discovery in distributed systems. The code shows how to query a collection of heterogeneous resources and selectively filter them based on embedded metadata tags without requiring prior knowledge of the resource structure. What makes this distinctive is the use of a standardized metadata namespace to avoid collisions with application-specific metadata. The pattern works by leveraging a two-level metadata structure where framework-specific tags live in a dedicated namespace. Resources expose their capabilities through these tags, allowing clients to perform declarative queries like find all configuration resources without hard-coding resource URIs or types. This creates a loose coupling between resource providers and consumers, where new resource types can be added without breaking existing clients as long as they follow the tagging convention. This approach solves the common problem of resource discovery in dynamic systems where resources may be added, removed, or modified at runtime. It's particularly valuable in microservice architectures, configuration management systems, or any environment where you need to discover capabilities without tight coupling. The trade-off is that you rely on consistent tagging practices across resource providers, which requires either strict conventions or tooling to enforce metadata standards. Let's break it down line by line.
Async with client.
Async context manager pattern ensures the FastMCP client connection is properly initialized and cleaned up after use, preventing resource leaks. The async with block handles connection lifecycle automatically.
Resources equals await client list resources.
This fetches all available resources from the FastMCP server asynchronously. The await handles the async operation, preventing blocking while waiting for the server response, which is critical for performance in resource-heavy environments.
Hash filter resources by tag. Config resources equals.
This begins list comprehension filtering to isolate configuration resources. We're processing the raw resources list from the server, extracting only those tagged as config in their FastMCP metadata. This pattern efficiently combines iteration and conditional checks in a single readable expression.
Resource for resource and resources.
This is a list comprehension iterating through all resources returned by the API. It processes each resource individually, enabling the subsequent filter conditions to evaluate metadata and tags. The pattern efficiently transforms the raw API response into a filtered collection in one pass.
If hasheader, resource, meta and resource meta end.
This performs defensive attribute checking before accessing meta. It first verifies the attribute exists with hasheader, then confirms it's not none, preventing attribute error crashes when processing malformed resources.
Resource meta get FastMCP end.
This is defensive dictionary access. It safely checks for the FastMCP key, returning an empty dict if missing to prevent key error. The pattern ensures the next chained get call always has a valid dictionary to work with.
Config in resource meta get get tags.
This performs safe nested dictionary access to check for the config tag. It uses get with default empty dicts to prevent key errors if either fast or tags don't exist, making the filter resilient to missing metadata. The pattern ensures we only select resources explicitly tagged as configuration items. This closes the list comprehension that filters resources by the config tag in their FastMCP metadata. It finalizes the collection of matching resources, which we'll use for subsequent operations.
Printf found len config resources. Config resources.
This outputs the count of filtered resources, providing immediate feedback about how many configuration resources were found. Critical for debugging and verifying, the tag-based filtering worked as expected. Metadata filtering pattern. FastMCP's tag-based resource filtering demonstrates how metadata transforms from optional documentation into active control logic, with the fast namespace ensuring clean separation from user-defined attributes. The include fast meta server setting silently changes what metadata is available to clients, potentially breaking filters if disabled. Always verify metadata presence with defensive checks like hassetter and get before accessing nested structures.
The tag that names nothing controls everything.